Morning, everyone. So this video might not be interesting to most of you, but I figure I might as well record myself if I was going to do the math anyway. So we talked about some math on the last video, and I'll kind of show you some of the math I like to do besides that program I was showing in the last video. So the question we want to answer today is, and I posed this in the last video, it's kind of like when there's 2 versus 3 dice. We're going to go with that example to start with. Is there like a value in, I guess, the casting value that you choose? It's kind of like that idea, right? If you have a 5 to cast spell and a 9 to cast spell, and you have 2 dice versus 3 dice dispel, yes, you're not likely to get the 9 dice, a 9 to cast off on 2 dice, but there's a range where you get the 5 to cast off and not the 9 to cast, and the enemy's going to dispel it anyway, and then the range where you're probably actually getting the spell off, you're probably rolling the 9 plus anyway, so you should actually go for the 9. And I think inherently that kind of makes sense, like, to say it to people, but here's kind of like let's go for that. So let's just do some math to see maybe if we can see something for it. So you could probably get a distribution of what's the chance of rolling 2 to 12 on 2 dice, and what's the chance of rolling 3 to 18 on 3 dice, and do some situational thing where, like, what's the chance you roll the 7, or I actually think it's kind of weird to set that up. So when I do math like this, I like to do simulations. So I use Excel for this. So as you can see here, we have a little chart that I'm going to need that kind of, and I'll show you a little bit of Excel tricks, I guess. So this chart is how we're going to simulate dice rolls. So there's a function in Excel called rand, and all it does is, I'm just refreshing, it just picks a random number between 0 and 1. I don't know how it does the random number. Maybe it's UB code like and it's just wrong, but you can see that, right? So what we're doing is we're going to set up a formula that says equals, I don't know if anyone's ever done a VLOOKUP in Excel. I'm sure some of you have, right? And we're going to make this one big formula in the end, but you'll see. 2, true. So what this is doing is saying, look at this distribution, right? And then find where this fits, and that's the whole. So I say, just to explain Excel a little bit, take A1, which is this cell, look at these 2 rows, which is VW, match the second one. So when it gets a value from this table, it'll pick the second row. So I'll give you an example. If we pick 1, it does 0.833. And so that picks the first one. And then if this was a 2, it would be 6. But I guess this might be the best start. So what it's doing is saying is, where on this spectrum does this number lie? And when you do true, if I was to do false here, it would be NA, because it would be looking for an exact match. So this number, random number, would have to be exactly one of these 6 numbers, which obviously it's not going to be. So we put true, and what true does is it matches the closest one without going under it. So in this case, it's saying 0.5, this 0.55 is between these 2, or it's lower than this one, but above this one, it's going to pick the 4. Okay? So, and we'll see that when we pick the 2, watch. So now this is 0.093, which is lower than 0.116, but higher than 0. So it's going to pick a 1, and then, oops, wrong button, F9. It keeps rolling, see? See how that number changes? And sometimes it'll be a 6 if it's high enough. There we go, there was a 6 right there. All right, so, and these are evenly spaced 1/6 apart. That's just what the formula is. And so for this, we can make this essentially a formula. So if we lock this so it never moves, and then we say random here, this formula now, no matter where I paste it, will just be a dice roll. And every time you paste something, it updates, so it'll do that. So you'll see how we do this. So now, what I have is this formula that essentially simulates dice, and I can do anything I want with it, right? So what I like to do is it's called Monte Carlo testing, which essentially you do like um, thousands of simulations and then use that to get your distribution. So if you did this, so let's just take a very simple example, right? And we'll look at, and we can actually use this chart. So equal count. So we do count if, and we'll say if this range equals this number, right? Oh, wait, oh, nope. It's supposed to be a comma there, sorry. Right? So there's 0, this will make sense when we do it. Drag it down. So it's only 1 because there's only 1, 5. It's just counting this column. But let's just do, for shits, I don't know, 600? Let's pull 600 down. Okay, 600. So now it should be close to 100, right? Of each. Right? That's within range. If you keep, I'm refreshing. Oops. Refresh. It's pretty close to 100. Sometimes you get in the 80s. I mean, I've clicked it a couple times, and there's a 70s. I've never seen a 60s, though. But that's random. That's how it works. And if we pulled this number down 10,000 times, I'm sure the numbers would be even closer to what the distribution should be. So if you do it enough times, law of large numbers, you can get the results you want. So how do we set up a nice simulation here? So let's take what we want to do. We want to cast a spell on 2 dice. So we're just going to color this column. And you know what? For your guys' sake, I know we don't do this, but I'll do casting roll. Casting 1, casting 2. So this is the first and second dice you rolled to cast. And then we'll say dispel 1, dispel 2. Oh. My typing isn't great. Did I spell that wrong? I might have spelled it wrong. Who cares? It feels wrong, but maybe not. And we're gonna color this. Actually, we'll color this green because it's the good one, and we'll color this orange because it's the enemy. And then we can just pull this across and say, all right. Oh. There we go. So now this is simulating. I rolled this dice. Enemy rolled their 3 dice, right? So how can we take this and make it an even more interesting? We could just say equals sum this, right? That's the casting total, and that's the dispel total. And we could say if, and you could make this like one formula, but I like to do this. If this is less, if this is less than this, 1, 0. 1, 0. Oops. Right? So now it's saying, so in this situation, the spell is successfully cast because 8 is less than that. And if we do it enough times, it's 0 because 7's higher. You know, just look, you make sure the formula works. Okay, so you could technically take this and let's do it. Let's just pull it down. The reason I wait till the end to pull it down is because every time you refresh, it will do it again. And if you have like 10,000, it might slow down your formulas, especially when we get into more formulas. So let's just randomly do, I don't know, 2,000-ish. So there's 2,000-ish. We did 2,000 exactly, actually. So if we sum this, and that's the reason I do 1s and 0s, is because I can just sum this, and every 1, right, is a past spell equals this divided by, we know there's 2,000 rows. I could have done it a different way. So there's a 40% chance, and let's just do random and see what we get. So if you're casting on 2 dice without any bonuses, there's like a 40% chance you beat 3 dice. That actually feels much higher than I thought it would be. Is that right? Did I do the formula? I summed that? Nope, I didn't do it right. Okay, good. That makes sense. I was summing 2 numbers. See, this is why you always check your formulas. That didn't feel right, did it? There we go. Let's just do this. We'll just bring it down. There we go. 16%. Wow. There we go. That feels better. I was like, 40% seems ridiculous. All right. So this is like a good start. There's like a 15% chance, and you could have easily done this math otherwise, but let's make it another step forward. So, because there's more steps, right? This is total casting. Is it 1L? It's 1L, isn't it? I don't know. No, I don't know. I don't know why I'm worrying about this so much. All right. Excellent. That makes sense. Okay, perfect sense. So now we're sitting here, but so now we know how 2 dice beats 3 dice. But that's not the question we're asking. The question we're asking is we have to layer in casting spells, right? So this is actually an interesting point just to start with. But that's, like I said, that's not what we're getting at. So let's do it a different way. So we're going to need some inputs over here. So let's do casting value, casting spell. What's the word? Casting value or roll needed, right? And we'll just, since it's 2 dice, we're probably only looking at spells that are like 5, 6, 7, 8, 9, 10, 11. Let's just look at these 6 rolls. So, how can we do this? Actually, it's probably not even going to be that difficult now that we look at it. Okay. So how can we set this up that we can get multiple results in a row? So this is one that kind of is interesting. We already know this, but let's move this to here. And so we need 6 lines, 1, 2, 3, 5, 6. We need the 6 columns. And what this is going to do is, and so this is for when the enemy is not a master wizard. We're going to be able to do this again with a master wizard. So we'll do it twice. So this will say if, and we'll just make it easy. Casting value will do 5, 6. So you have to know that the top is the casting value we need. Oh, I need another row. Shit. All right, 11. So let's just do, and I need to keep it like this because I'm going to use it for the formula. And we'll just underline it and bold it, right? So that's the casting value you need at the top. So you say equals if, right, this is less than this, and we'll lock the 1, comma 1, comma 0. How did I do it right? Oh, I didn't lock the right thing. I gotta lock the 1. There we go. So if F2, oh no, it's 0, comma 1 in this case. So we want the 1 to be if cast. So right, you see casting value 4. So if you do this, only the 5 goes off, right? This makes kind of sense. So if we want to do some interesting math here, right, let's just do this. Equals sum. Oh, sorry. I didn't lock the, this has to be locked on the F. So now we can drag it across, and this should make sense. So watch, this 10 roll obviously passes for everything but the 11. So let's look at this math, and I said there's 2,000 rows. Yep, so equals this divided by 2,000. Does the math check out? We know that rolling a 7, so this is the 5, 6, so this is the 7. Chance of rolling a 7 on 2 dice is, what, 1, 2, 3, 4. 4, 3, 2, 1. 21 out of 36. Seems pretty close to me, right? If you just, and this is, like I said, very close to that. This is why the simulation works if you do enough. Now this is only 2,000. We're going to up it to like 10,000. Like I said, you could do this hard math, not hard math. You could do the raw numbers, but it's kind of hard to like put them all together in string. So this is just double checking that it makes sense. It feels good, like, right? Because if this was 12, oh, I have to go 1 over. Sorry, I didn't do enough, right? Is there a circular reference. Whoa. What? That feels weird. Hold on. Oh, I see. Yeah, I gotta. This column will get in the way, so we gotta move it away. So now when we do 12, it should be what? Like 3%? Yeah. Okay, so math checks out. Excellent. All right, so now here we are. Now we need step 2. So this column actually doesn't matter. So step 2 is we need this to be, so this is, in fact, I should probably put this here. All right, that's there. We'll make it blue. So that's saying, is 2 dice greater than 3 dice? That doesn't happen very often, but so now we're going to redo this entire thing over here, and this is where the final answer will be. So we're going to say, all right, if this plus this equals 0 equals 2, comma 1, comma 0. And so this is fine. H has to be locked on the H. And the reason, so that dollar sign means, so normally, right, so it's these two. When I drag this over, notice how this box moved over 1, right? But the other box, if you look at these boxes, stayed the same. The dollar sign on the H locks it so that when you drag the formula, it'll keep it there on that box. So what this is doing now is saying, so these are the final answers. We're almost there, guys. These are the final answers. Let's just make it a whatever color. I don't know. This. Okay. So these are the final answers. And what it's saying is, if the 2 dice beat the 3 dice and gets the casting value, right, then what's the chances? So now this is where we get the answers, and we're going to drag them down even further, but let's make it interesting, right? So we will do, I don't actually like, we don't actually need these numbers anymore. Well, they matter, I guess. Okay, I'll do it this way. So we need to drop down, how many should we do? Let's do 10,000? Let's do 10,000 simulations. And we can just repeat it a bunch. So we're just dragging it down. This is the life of... There's probably a better way to do this, but sometimes the shortcut, I'm just too lazy to do the shortcut. I just do it the long way. Oh my god, get to 10,000. So I've done this. I should make a program that kind of keeps some of this math intact, but I tend to rebuild it almost every time. I actually think this is really fun for, like, I remember doing it once for Empire rockets, like the triple rockets, and like what the chance of killing things is. So now we have 10,000 rows of numbers. So what we can do is equal some, this. And we're going to have to move this over. It's refreshing every time I do it. That's why it's so slow. That's why you do it at the end. How many do I have? I need 2 more. All right. It's just not updating properly. All right, something's wrong. What's wrong? All right, this formula clearly isn't updating like it needs to. Let's see if I can calculate. Manual calculate. There we go. Now it's updated. All right, excellent. Now we do this. column is useless, so it's just these. And you can do equals, and you can just do divided by 10 equals. I mean, it's going to be a percentage divided by 10,000. Didn't have to put the comma. Shouldn't put the comma. Oh my god. There we go. Make it a percent. 4%. Oh, let's make this bigger. All right, guys, update. Damn it, come on. I know the formulas are intense, but it shouldn't be this hard for this thing to do this. Home. Formulas. Okay, what's... All right, update. There we are. All right, we have now done 10,000 scenarios. And what did we find? This feels wrong for some reason. Does it feel wrong? Something feels a little off to me. Inherently. Let's make sure we're doing stuff right over here. Because we said it was like 16%, wasn't it? I mean... Is it only that? Oh, let me just make sure this formula. If G2 is less than... That's right, because you have the advantage. It wasn't 16%. What? We had 16% before. Why is it down to 4%? Drew's doing it right. We're adding those two. That number seems really wrong. Is it just me? Did we not drag it down all the way? Is it really that rare? Oh no, it's doing something's wrong. Oh, I see it. Okay, good. See, this is how you know you did something wrong. This column didn't get dragged. I must have missed the first column. Okay, this makes... It was supposed to be 16. Jesus. This is easy to fix, though. All we gotta do is drop this. Yeah, I didn't drag this one down. It also makes sense because we did 2,000 before and went to 10,000, and we were seeing 16%, and now we're only seeing 4%. So that's actually not crazy at all. Okay, there we go. There's the numbers we were looking for. This is like that 16%, 15.1. All right. So here's where it gets, the analysis comes in, right? These are the key numbers right here. So what's the chance on 2 dice? This is the question. What's the chance on 2 dice if you need a 5 that you get the spell off verse 3? It's 15%. But look at this number. It's probably the break point is around 8. Like, it's only 2.3%. Like, if you, what's this is saying right here, like the 5 versus the 7? It's saying that there is only 0.8% of the time will you have gotten the 5 to cast spell off and not the 7 to cast spell off. That's what it's actually saying. So when it comes to the 9, what it's saying is about 4.5% of the time you would have gotten the 5% spell off, 5 to cast spell off, but not the 9 to cast spell. So the question isn't, you know, people want to look at it in steps and say, man, rolling a 9 is tough. I don't know if I want to roll a 9 on 2 dice. But there's only so much value in between. So if we want to do the math a little differently, like, right, if we were to count this, it's 83% to roll a 5, right? We could do this math without doing this. We just know the odds of through 2. And it's, you know, 28% there. That seems a lot worse. Like a 50 some percent, an 80% chance versus like a 20 some percent chance or 30% chance. But that's not the question here. The question isn't 80 to 30. The question is how likely are you to get to the end result that you want, which is casting the spell. So depending on the value of the spell, you're probably better off, especially if you're like in this range. 5 versus, I still would think 5 versus 9. I think maybe 5 versus 10 is where it starts to, the margins start to get thin. But you got to remember that the 10 to cast spells are stronger, right? So if the 9 to cast spell is significantly better, because usually a 5 to cast is like what? A D6 Strength 4 Magic Missile or something. Now, there are some good ones out there like Breath Corruption and whatnot on your own model. But I think what the question here is, if you can do D6 Strength 4 to somebody, or you could try to get off like a big buff or snipe or something, then fucking go for the big one. I think actually one of the most interesting ones is maybe this value right here, because a perfect example of this is lethal strikes, right? Reroll to wound. You got to value how important reroll to wound, the lethal strike part of it is. Is it worth the 5% chance? So there's that 5% windows, right? It's 85% chance you don't get the spell off, and 5% chance, you know. So I guess what this tells me roughly is 85% chance no spell. Oh my god, every time I type it's going to update. Oh. Then it's going to be, and actually how we can do this easier. So one thing I like to do is, so the only thing, these take up a lot of, is I like to just make these the values. So now we basically lock the math in. Now the dice rolls will never update, no matter what I do. So I locked in 10,000 rolls, which is fine. We can still change it. So there's 85% no spell. 15%, and then of the 15% left, you could say 10% 9 casting, and you infer that if you're getting the 9 casting off, you're getting the 5 casting off, obviously. And then there's 5% 5 casting, right? So there's only, this is the only window where it's, or 6 casting, sorry. This is the only window where it kind of sucks, right? This in between. And I think there's actually a legit decision there. I think if it's 6 versus 8, it's almost always you take the 8, assuming the spell's better. And let's just do it real quick with a master. I think all I have to do is add plus to this, +1. Let's just see how the numbers change. Let's lock these numbers in. So these are the numbers without a master. And let's do it with a master. Oh, look at that. Look at that math. Look how that changes it. So we're just going here. Oh, we gotta paste the values. Hopefully I did this right. I think it's right. Even more so with a master. I mean, look at this. You should, if you have 2 dice left, just roll a fucking like 8 up on spells. It's so much, it's not even close. Like, for like 2% difference for the 5, like, I mean, this is, there has to be in your head some implicit difference between the 2 casting, right? This isn't to say like, if the 5 spell is better than the 8 spell, just cast the 5 spell, 5 cast spell. But if the 8 spell is like potentially way more groundbreaking, then go for the 8 spell, because it's only that real shitty value, that 2% chance that you would have got the one off. So it's you know, this is, I mean, these aren't even barely even close. I think it gets interesting here. Like, think of it this way, like a 10. So there are some big spells off there where you're like, is it worth it for me to try to roll, you know, to get the 10 or not? I don't know. That's interesting. Yeah, okay, so the math is different because, yeah. So, anyway, this is kind of the thing I wanted to do. So, I don't know how I'm going to use this particularly. I think it could be interesting to do it with different dice rolls. Even like 3 versus 3 dice. There's some interesting there. Like, how much is it risky? So, think of it on a 3 versus 3 dice case. It might be... Actually, we can do it pretty quickly. All right, let's do it. Oh, I shouldn't have locked all the goddamn things. I shouldn't have. Yeah, okay, I messed up a little bit. All right, we can do this. It's going to be random. I shouldn't have locked on my things. This should work though. So that gets me a dice. I can drop it all the way down, and we will do some A2. Let's analyze one more set of numbers, guys. Okay, last set. Oh, this is actually even more interesting, probably. So this number is saying 3 dice on 3 dice. Look at this. I think this is super interesting here, right? 3 dice on 3 dice. What it's essentially saying is, if you're gonna get the fucking spell off, you're gonna roll probably an 8 or 9 or higher. So if your casting value, like lethal strike versus non-lethal strike on, say, Spectral Blades, like the value is super low, right? Like it's like 1%, 1.5%. 1.5% of the times you would get the non-lethal strike version off versus the lethal strike version. Where it's saying most of the time, almost every time you get the spell off, which is like 54%, you would have gotten the lethal strike version if you went for it. That is like interesting math, I think. That right there. And it's like squeezing value out, right? There's times, even myself, where I'm like, well, I don't, like, think of it this way. How many times have you told yourself, potentially, I don't want to risk rolling an 8 on, and this, I've happened to this. In fact, let's just do it without the Master Mage. This actually comes up more for like my Adept or something, so this is why I want to do it. Let's see how the numbers look. Okay, there's been times on my Adept where I've said to myself, I don't want to risk not rolling the 9, so I'm going to go for the 6 to cast Lethal Strike on 3 dice. And let's say the enemy has 3 dice. Then this is the only value I'm getting. I really shouldn't do that. So now if we do sum this, that should be this one. So this is telling me divided by 10,000. All right. Oh my God, update. Why are you so slow? Oh my God. Almost done. Almost done with this fucking thing. All right. Final commentary right now. Let's do this. What this is saying is, if there's no Dispel dice left, there's a 21% chance between the two. There's a 25% chance you don't get the 9. So maybe you say, well, I don't want to take the chance I don't get it. I'll take the 5% chance. I don't need Lethal Strike that bad. Obviously, if Lethal Strike is amazing for you, you take the Lethal Strike. You have to make that decision. But if they have Dispel dice left, you might as well go for the 9, because the chance is if you roll that 6, 7, 8 range and get it off, there's a very good chance that they're going to Dispel it back. Because not only do you have to roll a 6, 7, 8 specifically, but also they have to roll lower than that to where this is a difference. So that's why it's kind of interesting. And so that's something to think about. I mean, that's really like I said, I think when watching a lot of games online and listening to people talk, there is a lot of like, I mean, the math people use is very high level, right? It's very like the average. And we've talked about it in my last video. The average does this. The average does that. There's way more to it deeper than just knowing that Grave Calls averages half a wound or stuff. I mean, you could go in. We talked about variance before, in that you can't depend on averages, but you know, there's something to be said for. I'll give you a quick example since I'm on the topic. Graves Calls against 4-up save knights. Or, sorry, 1-up save knights, right? 7 hits. Let's say they need 2s to wound. It's probably 6 wounds. 4-up save. 3 dead. In fact, it's slightly below 3. Slightly. And you could say something like Big Haste in the Hour is 3 auto hits. 3 dead knights. Which spell do you prefer? Which spell is better? Which spell, right? On average, versus 4 up save knights, it's very close. Very, very close. And you could say there's ranges. Grave calls it slower, lower range. You have to sacrifice something. Yeah, I mean, that's pretty big there. And obviously, I'm using a 1-up save knights as an example because the math is very close. Obviously, if the save gets worse, grave call gets better. And as the toughness changes, it changes too. But what I'm trying to say is, would you rather take 3 auto wounds or 2d6 strength 6, right? And it really comes down to, it's not just math on that, because math says it's very close. Math says you want to take the Graves calls. But if you have 5 models, you might not want to take the grave calls. You might not want to risk, because there's something to be said about doing 3 wounds and knowing you only are going to lose 3. If it's the end of the game, right? Grave call doesn't give you that chance to, or the other spell, hasten, doesn't give you that chance to spike and get the other one, right? So it depends on which side of the board. It depends on the game state and everything. But that's like an interesting thing of, Hand of Heaven's a great thing. When it does 1 strength 1, you're happy as the non-caster. When it does 7 strength 7, you're appalled. But there's times where you say, I know what I'm getting into. There's a lot of time. I haven't done Hand of Heaven math yet, but I'm sure it's very interesting in just how skewy it is. Like, it is super skewy compared to, say, I don't know, something else. So, averages aside, you have to make dispelling decisions and game decisions based on things like that. That's why, like, auto hits are so strong, or like taking a cannonball is so polarizing, because the average might be 2 wounds or 1 wound. Let's say you shoot a cannonball at somebody and the average for whatever you're shooting is 1 wound after the D3 and everything. Well, that doesn't happen very often, right? It usually does like 0, 0, 0, 0, 0, 3, 4, 2, something like that. So can you take, it's one thing if they said, oh, you can only do 1 wound. It's another, it's only going to do 1 wound automatically. It's another if it's like, I think a great example there is like Haste in the Hour or Mark for Doom. Would you rather take the 1 wound? So Mark for Doom on a character with I don't know. I'm not going to do all the math, but let's just say, forget it. Don't worry about that one too much. But like Mark for Doom can skew to D3 wounds. It could also do 0. It's not a good comparison to Haste in the Hour, because Haste in the Hour does only 1, and Mark for Doom will do more on average. So I don't want to actually use that example anymore. But it's a good thing to think about, like is there a chance that it skews high or not, or do you want to take reliable, like it's pretty much going to do? Like Toxic Breath Weapon is so scary because if they spike on 6s, it's fucking amazing, right? And actually, Toxic Breath against some units is like just as good as Grave Calls, which is kind of crazy. Anyway, that's this video. Hopefully it was at least a little interesting to kind of hear about how to do a simulation in Excel and how to like think about different things. I do that once in a while when I think of some like situation I want to map out and kind of get an idea of, what's the best decision. Anyway, thanks for listening.